Okay, so I'll just introduce myself. My name's Aidan. I work for a software company in Australia, so I work remotely from a home office here in Cork, and doing sort of microservices with a mixture of .NET and Node.js on a mixture of Amazon and Microsoft Azure. And I'm the Ireland's only Microsoft Azure MVP, so if you're doing stuff on Azure, give me a chat afterwards, because I'd love to know about kind of local projects that's going on in Cork. So tonight's talk, I've got to put a big warning up here. There's no code on it, and I've been to a few of these chats before, and this is a talk about architecture and evolutionary architecture. So it's really it's not a techie one, and I'm not going to be bringing up slides and demoing software and code, but it's more about I guess we've probably all worked on projects where they start off really well, and then over time the code just turns it gets really complicated and difficult to understand. And the whole idea with evolutionary architecture is, if as a development team there's things you can do to actually I suppose to try and keep your code clean and to make sure that it can evolve and change with your changing requirements. So that's kind of the talk in a nutshell. So I know evolutionary architecture is a big fancy word, but this is all fairly down to earth, based on like real world experiences. And if you have any questions, like just jump in. I'm happy to just keep this really loose. So as I'm going through slides, just jump in if you disagree or if you have questions, because I don't have all the answers at all. Okay, so probably like guessing by people's ages in the room, I don't think everybody here has had the pleasure of working on a waterfall project. But can you raise your hand in shame if you've worked on a waterfall project? Yeah. Okay, so probably half the room. Like it was horrible, yeah. So you'd spend 2 or 3 months figuring out exactly what you're going to build, and then you'd specify it and you'd write it down and document it and design it within an inch of its life, and then finally you'd come around and you'd cut some code, and about 2 years later you release it and you come up with like something like this. So it's, you know, aesthetically it's beautiful and it's a really clean architecture, and it's designed and it's extensible, but it doesn't fucking work at all, like, yeah. So that was the problem with Waterfall, you know. So there was great, there was really good techniques for designing software, and I think the software that was designed was probably better quality than what we do now with Agile. But like, you can't make you know, if the rolling pin doesn't make a slice of bread, what's it all about? So fortunately, those days are gone. And like the Agile Manifesto says, you know, the best architectures, requirements and designs emerge from self-organized teams. So you can't have somebody in an ivory tower coming up with big blueprints and designs and, you know, throwing it down to people to build. That just doesn't work. So with evolutionary architecture, the idea is that teams self-form, and there's things that you have to keep front of mind so that you can actually create software that tests and evolves with over time. But I'll put it to you that in 2016, you know, we've been building software for probably, I don't know, 40 or 50 years. And the most common software design pattern out there on greenfield projects is the big ball of mud, yeah? So hands up if you worked with a big ball of mud in the last 5 years. Yeah, okay. And I think I'm not going to go through all the symptoms here, but I think there's a whole kind of load of reasons why you end up with a big ball of mud. Like, nobody goes to work in the morning and says, I want to create a monster. I'm just going to write shit code that no one else can understand, or I'm going to build a system that, you know, can't be reused at all. So I think everybody goes to work trying to do the right thing, but you get stuck in the detail, or you know, you've got really bad deadlines, and you've got bad testing infrastructure around your code, and this code that's really, no one understands it, so you kind of dodge it and you put stuff on the side, and all of a sudden you end up with that big piece of dung beetle there. Yeah. So like, and that's kind of funny, because software craftsmanship, there's a big kind of movement now, isn't there, around you know, really clean code and good development techniques. But I think everybody kind of does it on their own without actually working together as a team and talking about these problems before you start building software. So what I've called the guiding principles, these are sort of 6 things that I think you should do with your team before you build software. And if you stick to these things, I think you're in a better chance of building software that you can maintain and that'll actually stand the course of a project. So that's the 2-minute pitch on it. So the last responsible moment, so I don't know if you guys have heard of this before. It's like it's not about procrastinating or saying, oh, I'm not sure what, if I'm not sure what I'm going to build, so I'll just go with my gut feel on it or something. The last responsible moment says that you should defer decisions until like the very, very last second. Like any design decision, there's no point making it until you've got as much information as possible. And the longer you wait, the more information you have. So therefore, like make as few binding decisions as possible when you begin a project. The ones you make at the start of a project, like your tech stack and what you're going to use for your database, like once you lock in on those, it's very hard to back out and change them. So build like a steel thread or like an end-to-end piece of functionality, but don't worry about making it robust or redundant or putting queues in there, and like use as few frameworks and as few tools as possible until you understand exactly what it is you're trying to build, and then slowly add more stuff in. Because everything you add in will slow you down, and it's stuff you have to carry with you for the length of your project. So does that kind of make sense? Last responsible moment. And I can give you 2 examples of this where I work at the moment. So one is that we're building like an online tax form system. So they're data entry pages where if you're doing an Australian tax return, you fill in all your details and it calculates how much you owe to the tax office, and then it lodges it. And like as a business, MYOB, where I work, we've done this with desktop software for years and years. So there's a real kind of a driver in the business to say, like, build a designer so that business analysts can build these forms and put all the smarts into the designer so that it's really easy to read and change the tax forms, because we're going to do them for years and years on end. But we took we stuck to our guns with the last responsible moment and said we're actually going to hard code the first form, and then the next one we build, we're going to build a little bit of a generic engine to figure out what the calculations look like. And now we're at a point where we probably built 7 forms, and it'll be faster to just finish them off by hand than to build a designer or a tool that we didn't need in the first place. So I think if you're really pragmatic about and really kind of strict about what you actually need to get your software going, it'll pay off in the long run. So in order to do that, with the whole lean, the whole lean startup, and there's a whole cycle here about build, measure, learn. And if you want to sort of set yourself up so that you can change over time, it's really important as you start building software that you step back and look at it and kind of learn from your mistakes. And really question, is everything I'm doing, does it make sense? And do I need all of these libraries before you go any further? Okay. The next one is continuous integration. So I think I think continuous integration is like the biggest single thing that slows down the agility of a team. So if you're brilliant at continuous integration, you'll have really good software. But if your CI pipelines and your testing infrastructure is really bad and brittle and slow, that's really going to hold you back. So continuous integration and really focusing on getting like a good clean build process up and running, that's the first thing you should do on any project. So, and then if you think about like an evolutionary architecture, if you want to evolve your code and change it over time, you have to have the right type of tests in place, because without the right automated tests, that's your kind of safety blanket that lets you change how code works behind the scenes. So like for me, a build pipeline has to be really fast and give you quick feedback. So from the time you check in your codes, I reckon you need to know within about 10 minutes if you've broken stuff, because otherwise other people are committing code and you just get these cascading failures and it'll take ages to unwind it all and figure out who broke the builds. So like a really fast build process and good tests around it. Also on tests, like I think everybody gets really attached to their unit tests and their integration tests, and once they work, you don't want to throw them away. But I reckon if a test has been staying green for 6 months, just delete it and throw it in the bin, because that code is stable and it's just going to slow things down. And you'll see the little green light that tells you your code still works, but do you really need it? Like tests are probably more valuable when they start going red and green, and that tells you that you have an area of software that needs your attention. So I'd say be ruthless with tests and just delete them if they don't serve any value. and on that, code coverage, like if you've a manager or somebody in the company that asks you what your code coverage stats are and why are they low, like just bring them to the top floor and push them out the window, because code coverage serves no purpose whatsoever. Like all it does is it tells you if it's very low, you need to write some more tests in one area, and that's it. Like if it's 50% or 100%, who cares? And you can have 100% code coverage and your code can be shit, or you could have 50% code coverage. But if you're smart and you're confident that you're testing the edge cases and the right things in your software, well, then you've done your job. Yeah. So I'm probably been a little bit controversial, but it's really just to throw it out there and let's chat about it. Yeah. When it comes to branching, I think you need to have like the simplest branching strategy imaginable, and I put it to you that this is how you should branch code. So have really short like branches, so maybe a few hours or a day if you're working on a feature. If it's not finished, put a feature switch around it and commit it to master. And as soon as you commit code to master, it goes straight to production. And I know that's kind of, it's quite confronting to think as soon as you check it in, it goes to production. But if as a team you actually like take that mindset and do it that way, you're going to make sure you've got good tests around your codes. And it actually sets you up so that you can release your code really quickly. And you don't need to configure fancy build pipelines, because master just means production the next time the server runs. Is anyone doing that? Is anyone just building off master? No? Are you using Git flow or some of those things? Yeah. Do you like Git flow, or does it sort of really get in the way?
I like feature branches, but I don't use the rest of it so much.
Yeah. Okay, yeah, because I think long-running branches are really dangerous, aren't they? Because to keep them up to date is a bit of a chore, and then it gets to a point where you have so many branches in your code that nobody really knows what they're all for, and you end up just pruning off branches that are there for no reason. So don't do any branching and just go from master. And the last one on testing, I don't know if you guys have seen the test pyramid before, but I think it's like some of the ThoughtWorks guys have come up with it, but it really says that you should have lots of unit tests and, I don't know, maybe 50% unit test, 30 API and integration, and then just a small number of UI tests at the end. And the reason for that is that these ones run quickly and they give you fast feedback, whereas the ones at the top are really slow and brittle to maintain, so you don't want too many of those. But there's a whole sort of an anti-pattern for this as well, that someone's called the ice cream cone. So if you find that if you step back and look at your test coverage and you see that you do loads and loads of manual testing and then you've got a bunch of automated GUI tests, I guarantee your build pipeline is really slow and it takes ages to actually get your software out the door. So you need to go from the ice cream back to the sort of pyramid as quickly as you can. And the final bit on testing is around packed. So this is especially if you're doing microservices architecture, or you've got a bunch of services that you build and maintain. Like packed for me is like unit tests for services. So it's all about the person who consumes your API has to have a conversation with the person who builds it, and together you have to agree on a pact. So the contract for what your API is going to serve out for a known set of parameters. And then that pack file gets checked in and added to the build server as part as like an artifact in your repository if you're the service provider. And every time you build your service, you run these pacts. So it gives you confidence then that all your API consumers, that their code will continue to work as your API changes and evolves. So I think if you haven't looked at pacts and you're doing service-orientated designs or microservices, it's really powerful and it's very quick to get going. Okay. The next one's documentation. So the Agile Manifesto says something like it prefers working software over comprehensive documentation, but it doesn't say like no documentation. And a lot of agile teams kind of give up on documentation altogether, and they just say like code is self-documenting and it's a waste of time. But I do think you need like really, really lightweight documentation so that other people can join your team and can work with you and understand how the system works to help it evolve. So when it comes to documents, yeah, I think the first thing is that if you have any technical discussions or decisions that are made by email, you should just stop doing that and put all of that stuff into a collaborative tool like a wiki or Yammer or Slack. So somewhere where people can come back afterwards and actually look at it and understand how you came up with the design that you had. So like emails are documentation in my mind. And then when it comes to like kind of more formal stuff, system diagrams are really important, but they don't have to be like fancy documents. I think that can be a whiteboard sketch that's photographed and stuck in a wiki. Design decisions to sort of back up why you did something, and operational instructions so someone else can actually pick up the code and get running. All of those things for me are really important, and they will last the test of time if you just keep it lightweight and to sort of that level. Do you guys agree? Or anybody into doing more documentation than that, or does that sound about right? Yeah, okay.
How do you feel?
All unit tests are great for documentation.
Say again?
All unit tests are great for documentation.
Yeah, you're being able to read tests that describe how the code works, absolutely, yeah.
How do you feel about documentation in your code, JS docs type thing, that's generally
Yeah, like I think if, like, I love simple code, so I'd much prefer, like, if you can do something in 10 lines, or you, like, really cleverly, or you can do it in 50 lines and it's simpler to understand, I'd go for more, I prefer simpler code. And I know that's a real, like, so I don't really do much functional programming at all. Like, I think functional is really smart, and I'm not clever enough to get it. So I actually prefer simple code where you don't have to do lots of inline comments. But that's just my personal preference. It probably depends who you're working with. You know, if you're all doing functional and you all get it, that's great. But I think if you've got a mixture of functional and non-functional guys, then somebody's going to win. And for me, I think simple code means there's less bugs because it's easier to understand as well. So I prefer something longer without documentation than smart and clever. Yeah.
May I ask, would you give any tips to young developers that join a team that is not agile and don't do any documentation?
At all, is it?
Yes, at all.
Yeah. I'd actually start with the wiki, and like the next thing you're working on, just get your thoughts down on paper first. Or like, I know it's not paper, but write them down, because the other thing is that going through the process of figuring out a design and documenting it, like, gets it straight in your head.
Oh, so make your own mini documentation.
Yeah, do your own thing, and then ask them to review it, especially like a wiki. You know, people get kind of addicted to wikis and jumping in and correcting things and asking questions and challenging you, but like, it's much better to have that conversation before you write the code than afterwards, you know? And if you're a junior developer and somebody says, why did you do it that way? You know, why didn't you use this framework, or why didn't you do it this way? Like, if you put it down in a wiki first, they've got their opportunity to give you that feedback. So that's probably what I do. Yeah.
Thank you.
The problem is often it will get documented day one, but it doesn't exist as a living document.
And it goes out of date.
Code changes, and then you come back to it, and it's so far gone that you have to start again, and you probably don't bother because you haven't assigned time for it.
Yeah. And that's where I think like napkin diagrams or pictures are really powerful.
Yeah.
So a few pictures that actually show you all the big services and how they hang together. Like, that's really useful, and if there's only a small bit of it,
as long as it's in an editable format.
Editable format that you don't need fancy tools to update, to maintain it. Yeah. Okay. Continuous delivery is the next one, and like, I know this isn't possible in every company, but you really need to like talk to your product people and the non-technical people about moving to a continuous delivery model. And there's a thing in here that took me ages to sort of understand, but there's a difference between releasing code all the time and releasing new functionality. And continuous delivery just says that we're going to push out code changes as often as we can, because small little releases, there's less chance of stuff breaking, you know. So you need to figure out how you can start releasing software and have it all turned off in production. And then you give your product owner a little web page or something where they can turn on the functionality. And then they still feel empowered so that they're doing a release, but you don't lose any sleep at night because you know your code is just kind of sneaking out there all the time. So the big thing there is that like deployments should be really boring. Like you shouldn't be sweating it when there's a release going out because it just happens every day. And yeah, there's another thing, like if you're bad at something, like just keep doing it and you get better at it. So if you keep doing releases all the time and it happens without any intervention because it's all automated, you're going to get better at it. But I know that's a little bit ideal because if you've got an established product, you have to make sure you don't break stuff as you're pushing out new code. But I think you can get towards it. So there's a team I work with in New Zealand, and they're kind of on a journey to continuous delivery now, and they've automated all the steps, but they actually manually run the scripts once a day because they still don't trust that what they've done works. But you can start off that way, or just pick one service and do it. But you'll get to the point where you just much prefer that the code goes out there with no intervention because little deltas and little changes is much, much better than big bang. Okay, and then I think I've about 3 slides left. So the next one is, and this is getting a bit kind of fluffy, but you have to actually like think about your company and how big your company is and how that's structured when you think about how you're dishing out work and how you're going to work as a team as well. So like the bigger the company is, the more silos there are. And like even in small companies, there's little cliques and there's groups of people that have lunch together and there's other groups of people and they never talk. You want to make sure that when you're working on a project that you understand that and you make sure that you give those groups of people like different bits of product to work on. Because if there's silos in your organization or there's bad communication, like that's going to flow into how your software is built as well. So there was a guy called Conway, and he came up with this thing it's now called Conways Law, but he basically said that the structure of your organization will be the same as the structure of your code. So you either change your organization, which is really hard, or you make sure that you've got small autonomous teams and you have as little communication going between each of those different services so those bits of your product as possible. And that's how you actually get to build software faster, and it can evolve faster because like a small team that owns a piece of software end to end, they're empowered to actually evolve it and change it without having to talk to other people that they don't want to talk to in the first place. So Amazon has a thing called like the 2 pizza rule, and that says that if you take 2 pizzas, like that's as many people as can eat 2 pizzas, that's the size of a team, and one team should manage one service all the way from like dev to production. 2 people, is it? Yeah, yeah. So the whole idea is like don't have big teams and have a small team that can eat a pizza and actually manage the software all the way from like dev, test, and all the way to production. And then your software will evolve and it won't take on all the bad stuff that's there in every company with all of those silos.
So does that mean if you eat more pizza, you become more productive?
Yes, I think so. Okay, and then the last one is to design for replaceability. So I don't think replaceability is a real word, but if you know what I mean, it's like always thinking about what you build so that it can be replaced without breaking other stuff. So like a microservices architecture is really good for this because with microservices, each service has got its own like separate database on the back end. So as long as you keep the same contract here, you can rip out the database and replace it and change the technology that the service is built in, and all the rest of it will keep working. Whereas with a monolith, and you share a database across different bits of functionality, like it's a lot more brittle and it's much, much harder to actually replace bits of it without stepping on some other part of the system. So there was a guy called John Postal, and he was one of the early sort of inventors of like he really pushed along a lot of the internet, and he came up with this thing here called Postals Law, and he says like be really liberal or like accept anything in an API and just pull out the bits of data you need. And then when you're the provider of an API, just like send as little information as you can. So like be conservative in what you send, because as soon as you put an API out there, you're going to have consumers, and like it or not, you're going to have to drag those consumers and version all your contracts and deal with that for as long as your software is around. So like what Postals says is do the bare minimum with, like, send out the bare minimum, and then if you get more data in a message than you expect, just ignore it, but just pick out the pieces you need, and that helps set you up to have a robust service. Okay, so that's it. So in summary, like if as a team you want to evolve and have an evolutionary architecture, last responsible moment, continuous integration, some lightweight documentation, move towards continuous delivery, build like around the way your organization is built, and always think about replaceability. That's it. Any questions? No?
Do you know where you're working now? And I presume you're kind of based on a microservices architecture.
Yeah.
Did it start out that way?
It didn't, no. So it started out quite the opposite. So a lot of desktop software and then monolithic services in the cloud. So about 2 years ago we started doing like on a microservices journey, really, to be honest. And we're probably up to about, I'd say across the company maybe there's 40 microservices now in, I don't know, 6 or 7 different languages. But the teams I work with, we made a lot of mistakes along the way. Like we tried to build too many services at the same time, and we started building like 7 or 8 microservices without knowing what we were doing. So I think the whole thing there is, like, as a company, if you're moving to microservices, like, just do one and get it right, and really understand what it means from like a DevOps perspective and all the tooling you need around it, and then slowly start to move along on it. So I think it's better to have 1 or 2 bigger services and then split them when you actually know what you're doing, rather than you pull the firing gun and everybody runs in different directions, which is kind of what happens.
Okay. Did you try to preserve as much code as possible, or did, I presume you found yourself rewriting some of it? Yeah. And preserving some of it, like
we did. So and we put a lot of code in like packages. So we were using NuGet because it's .NET. So we were using package managers to share like copies of libraries across all the services. And I think if I had my time again, I wouldn't even bother reusing libraries across services. I think you're nearly better off having a copy of the code in each service, because the dependencies with those packages that you share actually slows you down as well. Okay. So I almost think when you go microservices, that code, like the one piece of code you build for a service, can be reused, but the stuff inside it doesn't matter if it's duplicated, as long as it's simple, you can understand it. Yeah. Okay, that's me.